Well, today we are here at the Blue Dragon. So today we have Mike Bursell on the podcast. Mike is a trusted board advisor. He is a C-suite executive, a cybersecurity expert, and a published author of the book Trust in Computer Systems and the Cloud. He is living in the Cambridge area in the UK. Mike, welcome to this episode.
Thank you very much, Dee. Great to be here.
For those of us who don't know you yet, can you take a minute and explain your background and how you ended up writing this book, Trust in Computer Systems and the Cloud?
Yeah, sure. Kind of weird background. My degree is in English literature and theology. I got an MBA along the way, but I was a bit of a geek, and I've been doing what is then used to be called security, now often called cybersecurity, for over 25 years. First as a programmer, then as a product manager, there's an architect, and then as a founder, CEO, and general all-round everything, really. And so I've been thinking about sort of trust and authority and how you do all of these things for quite a few years, sort of over 20 years. And I was at a conference a while ago, and there was a session which I went to, which had the word trust in it. I honestly can't remember exactly what it was or who gave it. But I was so annoyed at the end of that session because I just felt that the person talking about it really didn't have a good grounding. We didn't share the same language or the same frameworks. And I went to my boss, who was actually at the same talk, and said, "Look, I'm going to write a book about this. I've been thinking about it. I'm so annoyed. I'm going to write a book." And then I went and told another friend, and after that, I told two people, and I kind of had to do it. So that's what happened. I decided to put this together. And to sort of go from how do humans think about trust and what does that mean? And then how can we apply that to the world of computer systems and the cloud, and what's difficult, what works, what doesn't work? How do we build that up from the sort of first principles? And that's how it all happened, including things like open source, community, hardware, software, all of it together.
Wonderful. Well, the book came out, if I'm not mistaken, like 2 years ago or 3 years ago, and I read it last year.
Yeah, 21, 22, something like that.
Yeah, I read it last year on holidays, and I thought I'm going to finish this in 2 weeks, but it took me more time because it's so packed with a lot of information. You go back to the history of trust and from a philosophical perspective, and then you move towards a technological perspective. And that leads me to the question, Mike, like in a digital world, what is trust?
That's really tricky, and I spent quite a lot of time in the book trying to define what trust is and how to define it. Basically, the example I give right at the beginning of the book is I would trust my brother and my sister with my life. I do trust them with my life. But my sister is a dive instructor and my brother is a doctor. So I trust them to do different things, right? I wouldn't trust my brother to refill my tanks, right, for scuba, for instance. And so right off the bat, we know that we have different trust relationships to different people. And also those trust relationships are asymmetric in that, my sister wouldn't trust me to fill her scuba tanks. So it's not the same thing. Then, of course, there's the fact that we always have to think about context for trust. So is it the context of scuba diving, or is it the context of medical matters? And the last one is that one of the contexts should always be time. So in fact, my sister hasn't been a scuba instructor for about 10 years now. So maybe my trust in her to do that has changed a bit. And it turns out that when we're talking about digital systems or computer systems, all of those things still in play. So we need to think about trust relationships from one system to another, or from a human to a digital system, and think about, what am I trusting it to do? Am I trusting it to work correctly? Am I trusting it to keep bad people out? Am I trusting it to check that I am the person who I say I am? Am I trusting it to do what? And then within that, we think, okay, over time, do I trust it more because it's done it lots of times right, or am I trusting it less because, well, it's just been around for a long time and I'm not sure it's been patched? So there's all of those sorts of things fit in there. And you could say, if you've got two different systems, you might say, well, one system trusts the other to give it a good time signal. The other one trusts the other one to give it domain name lookups. And so that is, that's an asymmetric relationship. So all of these things really do play in the human and in the machine sort of cyber realm as well.
Yeah, what I like about your book is you really dedicated towards the concept of trust. Because me coming from a cloud background, what I hear here in Belgium with many organizations is, can we trust the cloud? We're moving towards cloud. What about sensitive data? Can we trust somebody else's data center, basically? So what is your thought on this topic, and also about the new rising theme of zero trust?
Yeah, sure. So I would say first thing is, come back to the question of definition. Trust the cloud to do what? So that's a really good question. Trust the cloud to keep your sensitive data confidential, to keep the integrity of it correct, keep it available, because typically we talk about the CIA triad: confidentiality, integrity, and availability. And so, which of those are you looking to trust it to do, and to what extent? And also trust it compared to what? So at the moment, maybe you keep all of your data on your internal systems, and you want to move to the cloud. So you're going to say, well, we're looking at relative types of, amounts of trust. Maybe we can say, well, internally, I can trust my systems administrators not to mess with the data, right? I hope I can. In the cloud, can I be sure of that? Well, I've got contracts with them, but I don't, with the cloud service providers, but I can't necessarily know that the systems administrators are not going to do that, or the cloud isn't, or that maybe maybe the cloud systems are more likely to be compromised. Maybe they're less likely to be compromised. And it's those sorts of decisions we need to make about trust in the cloud service providers to do what or not to do what. That is what we're asking. And to come to a slightly more nuanced answer to the question, I think that one of the things that people are asking a lot is, can I trust my sensitive data and sensitive applications? Because applications themselves can be very sensitive. You think about some of your AI, ML models, you think about maybe risk management models for banking, or those sorts of things, or even pharmaceutical research models, and saying, well, I'm not necessarily happy putting those in the cloud, because the standard virtualization and classical computing model provides no technical barriers to stop a malicious cloud service provider, or a malicious employee of a cloud service provider, or a compromised machine from looking at and changing your data and your applications. And that's a real problem. Now, I'm sure we're going to come to the issue of confidential computing in a bit, which is one of the ways of dealing with this. But straight off the bat, if I'm a regulator, if I'm a CISO, if I'm an auditor, I'm going to be asking the question, is the risk associated with this sensible? Because really what we care about is risk. And security is a tool in our armory as cybersecurity and business professionals to manage risk. And so what we need to do is understand the risk of moving our data and applications to the cloud relative to the risk of leaving it where it is. And partly that's a security risk, partly maybe it's a business risk. Maybe if I keep it internally, I can't scale as quickly or grow as quickly as I'd like. Whereas if I move to the cloud, I can move and scale quicker. So is that worth the risk to my reputation, to my financials, to my customers? And those are the sorts of balances that we as cybersecurity professionals need to help businesses understand and make.
Great. What about your thoughts on the rising trend of zero trust?
Yes, I've forgotten about that. That's a good one. So I think zero trust has been around for a while, and the idea is great. I really like the idea that you start off, by your default with each component on the system should distrust the others and only decide how much trust based on evidence, which is kind of the basis of zero trust. But the problem is that it's misused, the term, a lot. And people don't necessarily understand what it means. And one of the problems with it is that there is never zero trust. A component always needs to trust at least some things. And I'm much happier with the term explicit trust. So you know what you're trusting and you make it clear right from the beginning rather than zero trust.
That's what
And an example of that, coming back to the cloud question, is you're running a component, a container or a virtual machine or something like that, in the cloud. So that's a program executing the cloud with data. So how obviously, one of the things that zero trust is, well, when that component connects to another component, it needs to decide whether it trusts them. That's great. But how sure can that component be that what is the thing that is running it, either cloud service provider in those machines, is actually not malicious or compromised itself? So how sure can that component be of itself, of the infrastructure which is running it? And if the answer is not at all sure, then how is it supposed to manage communications with other components? And zero trust kind of falls apart if you don't think about that as well. It should always be explicit trust. And once we start thinking like that, we can understand again the risks of putting things in different places and building these architectures.
Yeah, I remember reading that chapter in your book on where you talk about zero trust, and you basically say a better name would be explicit trust. Because you have to verify all the time. And I really like that. But you also talk about the concept of a trusted computing base. So what is that and why does it matter?
Yeah, it's hugely important. And exactly the point I've been coming back to just now, which is that you need to have a base of things you can trust. Like if you're making a building, you need a base, a foundation that you can be sure of that's not going to fall apart. And the same goes for computing. You need to know that the stuff at the bottom it can be trusted. And typically, in cybersecurity world, we always want a hardware root of trust, something you can build on like that. The absolute foundation, one or more hardware roots of trust, and then the things on top of that. And the things you might be building on in a standard computing model would be your kernel, your hypervisor, your motherboard, CPU, RAM, all of those things as well. There might be some specific cryptographic libraries, maybe libSSL, for instance, if you're in the Linux world. And so understanding that those bits are well established and safe, and that you can have assurance, to use one of the words from the book about trust, assurance that they're going to behave as you expect them to, which isn't always necessarily as you'd want them to, but at least as you expect them to, allows you to build a trusted compute base. And generally, again, the dictum around this is that you want as small a TCB, a smaller trusted compute base as you can, because it's much easier to audit. It's much easier to check on the provenance, check on the supply chain, check the people who've been creating it, other people who should be creating it. In the news recently, there's been this the XZ or XZ attack on Linux, where we found that some of the people who were writing that code maybe shouldn't have been as trusted as they had been. It was caught, which is great. And we've seen other things in OpenJS as well. So understanding how your trusted compute base or TCP is put together and how it provides that foundation is really important.
Yeah, so what you're saying is that the trusted computing base should be as small as possible to trust as least parties as possible.
Yeah,
great. So, but then when you say it has to be rooted in hardware, I always think of an HSM, a hardware security module. And I know it's just one of the ways to have this trusted platform. But in your opinion or your perspective, when does an organization need to pivot towards an HSM?
Yeah, HSMs are kind of the gold standard, really, for security and hardware. And they're typically used, they came out of the military, basically, but they're used a lot in financial use cases as well these days. And the things they're typically used for are the absolute sort of the crown jewels, if you will, of an organization. A classic example is a root certificate for a certificate authority. Or I used to do some auditing for banks who were putting chips on your credit cards, and the keys, the cryptographic keys for those, they may be protecting the root key, 10,000 credit cards or more. And if you think about, each of those maybe has 20,000 euros as credit limit on it, just as a number. If that root key is compromised, you've got real problems. So putting them in an HSM is absolutely the right thing to be doing in that context. So, but the problem with HSMs, well, there's a couple of them. First is they don't scale very well. They're difficult to scale out. They're also very expensive, and they're difficult to use correctly. we have very complex things, mechanisms and processes to how to set them up. They're very difficult to program for generalized computing. So I think that their use is always going to be fairly restricted. But as I said, the gold standard, you've got really sensitive stuff, the root of what you're doing, and HSM is often the way to do it because they provide storage and some basic processing, typically cryptographic processing.
Great, great. Because now with cloud providers like Microsoft Azure, you have the option on a Key Vault to use, let's say, the default Key Vault, which is software based, or a Key Vault Premium, which has an HSM behind it, or even a managed HSM, especially dedicated towards your tenants. All right, Claire, so you talked about having a trusted computing base. You also mentioned briefly confidential computing. And that is, of course, a big chapter in your book, all about confidential computing. What is it and why is it so important?
So confidential computing provides chip-based, so hardware-based protection of your application and your data. And this is a whole new thing. So we talked about HSMs a little bit just now, and HSMs provide hardware as well, but they're sort of separate modules. This is capabilities built into chips by people like AMD or Intel or ARM, which can provide isolation of your applications and data from not only other applications or other containers or VMs or whatever, but also from the rest of the machine itself. So even if your hypervisor is compromised, even if your kernel is compromised, even if other parts of the hardware are compromised, or you have a malicious administrator, your data is protected. Both the confidentiality and the integrity of it is protected. And that means that you can start doing computation of sensitive data and using sensitive applications without necessarily having to go all the way to an HSM, because you can do standard computation with confidential computing with these chips, which are not just in CPUs, but now appearing in GPUs as well, sort of for AI use cases. Really exciting. And those are just available in the cloud providers. You could just ask for one of those. You'll pay a bit more for it, but that's fair enough, given the extra security you're getting. And there's another piece as well which comes into that, which is a process called attestation. And the attestation is a cryptographic assurance that each time you're loading your application, your data into one of these, what they call trusted execution environments, this confidential computing environment, that what you're loading is what you think it is, but also isn't something that somebody has spoofed. It's a real one of these and is based in the hardware, not a pretend one that someone's put together to try and steal your data, steal your application. So confidential computing is using these hardware-based trusted execution environments with attestation, and suddenly changes the way you think about cybersecurity, particularly in the cloud. You can use them for your own internal as well, but you can now put things in the cloud that you probably couldn't before. You certainly shouldn't be. Now, regulators are really unhappy about people putting financial data in the cloud, patient data in the cloud, credit card data in the cloud, about governments putting citizen data in the cloud. But there's lots of sensitive data and things like cryptographic keys, which frankly need better protection, and this provides it, because we've been using encryption of data at rest in storage, on disk, whatever, for ages. We've been doing encryption of data in transit on the network for ages, TLS, things like that, SSL. But this is the missing part, where you've got data that's actually being processed, being executed in RAM. And frankly, anyone with administrator access, kernel hypervisor access to that machine can do anything they want with it, until you start using something like confidential computing, which is, again, hardware-based.
Very nice. Yeah, I see it. In Belgium, it's really a niche or a niche segment at the moment. I had a client who was actually investigating it, and on Azure you have then the confidential VMs. You have Microsoft Azure Attestation, and you also are seeing this evolution of PaaS services being converted towards confidential. How do you think the future will evolve or will go with confidential computing?
Yeah, if you look at people like Microsoft, they're already saying that they expect within 5 to 10 years that almost everything will be running in a confidential computing environment. Because why wouldn't you? At the moment, it's why would you? But as it becomes cheaper and easier to do, and the maturity of the ecosystem, goes up, increases, and it just becomes easier to do so, it just makes a lot of sense because at so many times you've got confidential or sensitive data about your clients, your company, your operations, your sales, whatever it may be, your patients. Maybe it could be something as simple as your CEO's paycheck. Now, do you want someone looking at that? Do you want someone changing that? As a CEO, I suspect you're probably going to say no to that, right? And being able to protect this just as you do normal computation, it makes a lot of sense. Now, there are other techniques to provide some of these capabilities, and there's a group of different technologies called PETs, privacy enhancing technologies, of which confidential computing is one. And I think we're going to see them used more and more, and they're complementary. You can use them together in different ways if you wish. Okay. But I absolutely expect confidential computing just to become the norm as it's rolled into more and more chips. And becomes more generally available.
Wonderful. Yeah, when I talked.
Oh yeah, one more thing actually I should add, which is that we shouldn't just think of the cloud. We know more stuff's going to the edge, right? Automotive, people running servers in stadiums or autonomous vehicles or whatever it may be, and we're going to see more and more usage of these technologies like that. One really good example I came across recently was microsatellites in space. You want to make sure that the data that they're collecting is looked after when it's being processed, and you'll be doing some of that processing in space. You don't want to send all of it down to the ground. It's far too expensive. So that's something that you certainly want to be doing.
Perfect. So one of the things that I also see is I had a chance to talk with an Intel executive, and he mentioned that their vision of Intel is that even endpoints like smartphones and laptops will have confidential compute in the near future. You talk about between 3 and 5 years. So it really is a next evolution, let's say. Would you agree with that?
I really would. A lot of the work that's initially happened has been sort of in the high-end server grade market, but we're certainly seeing it come into the lower end server market and edge and things like that as well. And ARM has a technology which is coming out right as we speak, actually, called ARM9 CCA Realms. It doesn't exactly trip off the tongue, but that's what it is, which is a confidential computing technology. And we all know that ARM is used in so many different, not just server use cases, although server as well, that we can certainly expect it to be spreading out through the computing ecosystem more generally.
Great, wonderful. Now, something that is closely related to confidential computing is the concept of multi-party computation, MPC. What is it? How does confidential relate to it? And what's the benefit for an organization?
Absolutely. So sometimes you talk about SMPC, secure or secured multi-party computation, because multi-party computation is just allowing different parties to work on the same data together. But sometimes you don't want to be sharing all of that data. You want it to be mixed together, but not available to all parties. The classic example is you've got a pharmaceutical research company and it wants patient data from different hospitals. And firstly, those different hospitals don't want all of their data mixed together and available to everybody. Secondly, they don't actually want all of the data to be sort of stolen by the pharmaceutical company, and they'd like technological controls to stop that. So using confidential computing, you can create an environment and an application where you can prove to everybody that the data is not going to be exfiltrated. It's not going to leak out anywhere. It's not going to be available. That all that's going to happen is this application will maybe look over certain sets of that data and give a yes, no, or a percentage or whatever it may be that's needed for that particular piece of research and that pharmaceutical company is paid for. And suddenly it's okay to give my patient data to this application because I'm not actually giving it to the pharmaceutical company. I'm only giving it, and I can prove that it's only going to be used for the purposes for which I'm being paid for it, or to which my patients have agreed, or whatever it may be. And you can use this for loads of things like sort of voting, or looking at things like financial use cases, risk management, credit scores, so many different applications. And we're going to see loads more of them. So that's kind of what multi-party computation is. It's about allowing data from multiple parties to be computed on at the same time, and to make sure that only the things that should be happening are happening.
Wonderful. And the other thing that I see with confidential compute as a enabling security technology, let's say, is the combination with AI. And so now you have something called confidential AI. Can you share a bit more about what that is and what the benefits are for an organization?
Yeah, sure. So, I mean, I think there's two parts to AI, and we sometimes lump them together, and we shouldn't. So the part we see most of the time is the actual the use of an AI model. So I type something into whatever AI model I'm talking to, and it gives me the data back. Or I give it an audio file and it gives subtitles. I use that for my YouTube channel, right? I get subtitles automatically. Fantastic. Don't have to type it in. And in that sort of case, there are times when you want to be able to access that model without the owner of that model knowing exactly what you typed in, or what the information that came back, right? So maybe it could be to do with human trafficking. You don't want the details of someone who may have been human trafficked available to everyone who has access to that model. And so using confidential computing to protect that model gives assurances to the person accessing it that what they've got is being used properly, but also to the person who owns that model that only the right type of data is going out, rather than pretty much anything. So that's the second part. The first part is when you're actually training models. And confidential computing can help here as well, because in a kind of, it's a bit like the secure multi-party computing, in that you want to make sure that you know what data has gone in and it's only being used in the way you expect it to be used, right? And using some of these techniques, you can not only know that, but also track that into the final model where it's being used. So you can prove, you have assurances that only what you think has been taken on, and only the models you expect to have been used have been put together into that AI model, which then, having been trained, is used for the final model.
Very interesting evolution there. Yes, I can see the benefits, assurance, and having verified trust in the model, both in the training and the inference of the model. So really interesting there. Now, also a part of your book is a chapter on open source and trust. So how does open source relate to trust?
All sorts of ways. So open source is it's a philosophy, but it's also a community, right? And we need to remember that when we're creating software, when we're using software, we have trust relationships to where that came from, and how we have built those trust relationships is very complex. It's particularly when it's not just one, a proprietary company who's come up with this thing, this application. Because if it's that, then I can say, well, I've decided I trust them because they're on the stock market, and if they make a mistake, that their share price will be wiped off, whatever. If it's actually a group of individuals who, one based in China, one based in Canada, one Seattle, one in the Netherlands, one in Brazil, how do you build your trust in what they're creating and the processes they're doing? And so the book kind of starts to delve into that. And it's actually an area that I'm thinking of doing some more work and research on, because I think it's really important at the moment that we have models for knowing what and why we trust out of things that the open source community builds and provides. To give one example, I know some really good programmers, right, who I know have created some fantastic security software. And I trust they're good programmers, but that's different to saying that I trust that they're good cryptographers. They probably have taken a cryptographic protocol and implemented it, rather than checking that they believe that the cryptographic protocol itself is good. So I need to trust them for one thing, but not another thing. I need to have a trust relationship with another set of people or another community or another process to be sure that I trust the whole thing that is that security library or that security application, right? And so, and there's a lot more to that. Who's built it? Who created the hardware on which it was built? Who signed? All of these different things are about trust, or have to include trust relationships. And that is different in the open source world, and the business world and the government world and the defense world is having to come to terms with that, because they want to gain from the benefits that open source software brings to us all. And there's the figures that at least 70 and sometimes up to 90% of the software in any application is actually based on open source. So it's there. We have to think about this, but it's a new way of thinking. It's a new way of trusting. It's a new way of doing business, and that's why I think it's really interesting. You've got me going on one of my favorite topics, so I'll stop there.
Yeah, I had to think, like, years ago, I was on the IRC or Merck software, let's say, the channels, and you had software that you could add scripts from other persons, and they would enrich your experience on IRC and with commands and shortcuts. And one time I got this package, and it had some I would say encrypted lines, and I couldn't see what the script was actually doing. And all the rest was transparent. So I did not use it because I didn't trust what was behind or inside the black box. And what I like about open source, and that is I think the main argument is it's transparent. You can read every line of code. There is no hidden logic there. And that boosts trust with the verification behind it. That would be my point there.
Indeed, it should do. I think one of the problems that the open source community has become aware of over the last 5-10 years is that just because it's open source doesn't mean that someone will have looked at it. And if that person who has looked at it, if they're not an expert in that area, then it doesn't necessarily help, right? So we need to have expert eyes, particularly security expert eyes, looking at the code. And they need to be motivated and often paid. And this is a good reason why, if large companies are using open source software, one way to contribute back is to pay for these experts on their staff or elsewhere to be looking at this and auditing it and writing and testing this code themselves.
One of your chapters in the book also describes blockchain, or talks about blockchain. And the question that I now have in 2024, is blockchain, in your opinion, on the rise, past the hype, or almost dead?
I think blockchain's here to stay. I think it's one of the new primitives of how we think about computing, and I don't mean it in the standard, basic Bitcoin cryptocurrency, or even necessarily permissionless blockchains. We're talking permissioned blockchains, distributed ledger technologies, DLTs. However you look at it, the idea behind it is here to stay, and that's a good thing. I think it's fantastic. We've had some problems with blockchains and implementations, and the environment and stuff. That's I don't think here or there. It's a set of technologies which changes, sort of primitives change how we think about computing, and I think it's the same thing around confidential computing. Once you think of confidential computing as providing with new primitives, then it changes the way you think about architecting, designing, operating, and end-of-lifing software. And in fact, I think there's an interesting combination here. One of the drawbacks, shall we say, about blockchain can be that people see stuff on the blockchain and think, oh, it's safe, it's good. And the answer to that is, well, it's safe now, because it can't be changed without it becoming very obvious, right? But how sure are you that the processes that led it to being on the blockchain, this data, were protected? So smart contracts, we hear a lot about smart contracts leading to data which is then put on the blockchain. But those smart contracts may include data which is itself sensitive, either if someone could mess with it or maybe just see it, but certainly mess with it. And that's a bad thing, because if you can mess with the input, then I don't care if it's on the blockchain, it's not correct. It may be unchangeable, but it's not correct. So if you can prove using something like confidential computing, that what was created and put in the blockchain came from a known and trusted process, then you're in a good position. And the same goes for oracles that feed information either the blockchain directly or into smart contracts. You really need to make sure that those are protected. Whether it's a time source or the price of ice cream at 2:45 on in the afternoon on July the 3rd in Antwerp. I don't know, but whatever it may be, if this is important data that's going onto the blockchain or into a smart contract to decide really important things, you need protecting that. And so, one of the things about blockchain and cryptocurrency, it's sometimes called trustless. I don't think it is. In the same way that I don't think that zero trust is zero trust. It should be explicit trust. And so, yes, you may not be relying on a single centralized party, but you're relying on lots of other things, and you need to have assurance of their provenance, of their correctness, of their integrity, all of these things. And combining these different technologies, I think, is absolutely the way we should be thinking in the future.
Great. Thank you for that answer. Last question. What is in your future? Do you have any upcoming projects or a second edition of the book? What's up?
Well, as I said before, I'm really interested in doing some more work on sort of open source and trust and how that all fits together. I'm currently the executive director of the Confidential Computing Consortium, one reason I care about it so much. And I'm looking forward to continuing with that, because the ecosystem is really growing as the maturity of the technology and the software and the hardware around it increases. But yeah, for me, I think that continuing understanding how trust works, how security and trust play together with risk and business is really exciting. I've always enjoyed most being on the borderline between the business and the technology, and seeing how they interact and how they clash heads and how they can actually work together. And for me, these are areas where that's happening right now. So I hope to be doing that. One day I'll retire, but it's not going to be for a while.
Wonderful. Yeah, and I think Europe isn't helping, because with all the new legislation like NIS2 coming out, supply chain validation and verification, this topic of trust and risk management and confidential computing only increases. So we're on the starting point, in my opinion, of this whole track. So no retirement.
I 100% agree.
No retirement for the next few years, I'm afraid.
No, afraid not.
Mike, thank you very much for joining us today. I really enjoyed our conversation.
Thank you.
And have a nice day, and see you next time.
Thanks a lot. Bye.
Thank you so much for tuning in to this episode of the Blue Dragon Podcast, a podcast dedicated to IT decision makers and helping them gain perspective of what's going on in cloud, AI, and security. If you enjoyed this episode, please give it a thumbs up, like and subscribe to the channel so you'll be up to date all the time when new episodes come out. Your support really means a lot to me. Thank you very much. Have a great day, and see you next time.